Good morning, everybody, and welcome to our second webinar about nearly zero energy buildings. Today, we are going to shed some light on the topic of what technologies will make the cut in 2020. And before I introduce the speakers, I just want to let everybody know that the presentation will be made available to you after the webinar. So your speakers today are my colleague Stephen Ashurst, head of our Heating Insight service, and also one of our experts of the micro-CHP service at Deltaee Energy and Environment.
Morning, everybody.
And myself, Lucas Bergman, I am the head of Deltaee's Heat Pump Research Service.
So for those of you who are less familiar with Deltaee, I just want to give you a brief introduction to our company. So we are experts in heat and distributed energy, focusing on everything related to the demand side of the energy triads. Our research helps our clients understand the commercial propositions of low carbon offerings. We do this by providing market insight and forecasts, techno-economic analysis, competitor benchmarking, as well as strategy and tactic support. We do so across a wide range of topics, highlighted in the bubble graphic on the screen there, all of which are in one way or another linked to the demand side of the energy system. We have a number of particular research services as well listed on the screen, and two technologies that are covered by these dedicated research services, which link to the energy sector with the built environment, are heat pumps and micro-CHP, which will be our focus of the webinar today. So the information that we'll present to you is taken from an upcoming study, which is a collaboration between our heat pump and micro-CHP research services. The key aspects of which you can see on the screen. Our services help our clients identify and exploit market opportunities, understand emerging markets, emerging technologies, and key policies which shape the opportunity. They're an easy way to make sure that you stay up to date on developments in your study and save time by providing in your industry and save time by providing the key messages behind current developments. And I can see we have a number of subscribers on board with us today, as well as a number of non-subscribers. So great to have everybody on board. Our heat pump research service was established back in 2011, and the micro-CHP research service is Deltaee's longest running research service, now into its 12th year. So today we'd like to take you through the following agenda. As Lucas mentioned, this is the second part of a two-part webinar series. For those of you who missed our webinar before Christmas, or who might just be new to this particular topic, we'll have a very quick overview of the Energy Performance of Buildings Directive and the transition towards NZEBs. We'll tee up the main content of today's webinar by recapping on the main points from our previous one. And then we want to go on to highlight the criteria for NZEBs and how they are being implemented in some key European heating markets. Those of you that have looked into this topic will know it's one that raises a million questions. We've got time for two such questions or examples today to highlight the impact that the EPBD will have on the opportunity for both micro-CHP and heat pumps in particular. For those of you joining us who are interested in getting getting deeper into this topic, we will highlight the full breadth of work that Deltaee is currently undertaking for our subscribers, and of course there will be time at the end for some Q&A. So why look into this topic at all? Why is the EU looking at nearly zero energy buildings? We have some statistics on the screen, which we expect many of you will have seen already, but certainly worth repeating, we feel. Buildings are a significant source of carbon dioxide emissions and are major users of energy in the European Union. Homes, offices, shops and other buildings account for nearly 40% of final energy consumption and around 36% of total greenhouse gas emissions. Therefore, of course, reducing energy use in buildings is a key part of the EU's energy efficiency policy. Tackling energy use by the sector will help the EU meet its 2020 targets and also its longer-term climate strategy. The Energy Performance of Buildings Directive, or EPBD for short, is the main legislative instrument that the EU is using to improve the energy efficiency of member states' buildings. And the EPBD aims to significantly improve the energy efficiency and total energy consumption of buildings. It focuses on setting minimum targets for new buildings and existing buildings that are subject to major renovations. So this is in both the domestic and the commercial sector. A key part of the EPBD is the requirement for member states to ensure that by the 31st of December 2020, all new buildings are nearly zero energy buildings, and that's 2019 for non-domestic. What is a nearly zero energy building? Well, they're defined as a building that has a very high energy performance, that nearly zero or very low amount of energy required should be covered to a very significant extent by energy from renewable sources. And as is the situation with all directives, member states must draw up their own national plans for increasing the number of nearly zero energy buildings. So in our last webinar, these are the key points that we covered, the key issues raised. Number one, that to that point, evidence suggested that building regulations will be a huge driver of change in the heating market, more so than we have seen to this point. New build regulations from 2021 will, in most countries, have a significant impact on how we build our homes and how we heat our homes, perhaps how we cool our homes. There's a lack of clarity, though, around definitions and eligible solutions. And given that that is the case, Deltaee looks to bring answers to some of the many burning questions of the industry and with this research in particular, we've adopted a model-based approach to compare technology options in each market, and combining this with views from our wide network of industry experts. At the end of our first webinar, we were really interested to get a feel for the general European building and heating industry's perspective of the path we might be going down. So we asked a brief poll to assess what technologies you thought were set to benefit from most of this policy change. And we can share those results with you now. So we see from our results that the majority of people that answered felt that the EPBD would really kickstart the market for heat pumps. Perhaps the tightened thermal energy criteria in updated building regulations allowing for low temperature heat pumps to become the new base case, perhaps. Micro-CHP, you can see there, came in seconds, over 20%. Still seeing a really important role for high efficiency gas technologies in the future. This was closely followed by those who see perhaps an all-electric future supplemented by solar thermal. And other than those examples, what we can also determine from this is that we found a wide range of views of which technologies will win out. Ultimately, it'll come down to each member state to set the market on whichever path they see most appropriate for their own country. And this slide now gives an overview of, we have identified the key parameters that will be used in the specification of NZEBs in markets we are primarily interested in with this research, which, as you can see, are Denmark, Italy, the UK, Germany and France. So if we look at the row at the top of the table, maximum primary energy demand, we can see that all countries take this into account, but not all lead with this as the main criteria for measuring what an NZEB is, what it should look like and how it will perform. In the UK, for example, it's the only market that we've assessed where developers expect to have to build to a certain level of carbon emissions first with annual energy use being a secondary aspect. And then when it does come to primary energy demand, you can see that different countries consider different building loads to contribute directly to that target. Heating and cooling is of course expected. A couple of countries would also add lighting into this mix. France is a very interesting case. You see the question mark. There's a lot of debate regarding whether it takes into account the energy demand from domestic appliances, things like obviously fridges, washing machines, TVs, etc. If yes, this will likely see to French new builds being loaded with PV, as is our understanding, which can be quite interesting, especially if you're EDF. Lastly on this slide, if you look at Italy, its criteria for NZEBs is among the most ambitious in the EU. In commercial and domestic new builds, 50% of the max primary energy demand is to come from renewables. Many in the industry we have spoken with feel that this will be technically unachievable in some projects, especially in those commercial projects with high electrical loads, shopping centres for example. And so this will be a very interesting market to keep an eye on over the coming years with regards to how these the NZEB path is ultimately followed. So we hope that just gives a good overview of what the various member states are aiming for and how NZEBs will be specified. In a moment we'll go on to explain through two examples from Denmark and Germany how we have conducted our analysis on this report. But before we do so, just a quick note on the size of the domestic new build sector in each country, given that our main goal with this piece is to identify specifically how the opportunity for heat pumps and micro-CHP will be shaped by the enactment of the EPBD. You see there's a significant variation in the scale of construction rates. Currently, Denmark builds the least. The market in Italy is showing early signs of recovery after the past 5 years or so. And despite numbers picking up in 2015 in the UK, we still have a long way to go to meet our ever-growing housing requirements. By the end of the decade, an additional 100,000 homes per year are targeted on top of what is being built just now. And then we can see, on paper at least, the opportunity in Germany and France looks great, given the current size of the new build market and similar ambitions to grow it still out to 2020. But of course, size of the market is one thing, the criteria to meet are a completely different issue. So Lucas and I have prepared some examples today to show you how we have gone about our assessment of what the implication of the EPBD will be for different technologies, again with a focus on micro-CHP and heat pumps. We used this slide in our first webinar just to highlight the range of questions that are hot topics really in the industry at the moment, and you can see, or well, we certainly feel that there's lots of really interesting ones are raised by this issue. Today we want to cover how the opportunity for fuel cell micro-CHP looks in a heavily demand reduced environment, which is that question there, what role for controllable small scale generation technologies, and we also want to examine whether direct electric heating could become the next lowest cost solution in the new build sector. So now I'll hand over back over to Lucas, who will take you through our approach and our findings.
Thank you, Stephen. So, as Stephen already mentioned, we have developed a model which allows us to compare different heating technologies, 11 in total, in houses situated across our 5 countries. Inputs like the location, the use of heat recovery ventilation, insulation levels of the building and its floor size are used to define the building in which we model our heating system. Based on these inputs, we calculate the heating demand of the building, which then feeds into the heating system calculations and eventually into the key outputs of the model, which are then compared against the building regulation requirements of each country. Of course, important factors like auxiliary systems and the type of the distribution system are also being considered. We have packaged all this into an easy-to-use user interface, which allows you to define a building in just a few seconds with just a few clicks by choosing the desired values from drop-down menus. There are 9 locations in which we have placed the homes that we simulated. All have been chosen to represent the most important climate zones of each country on the basis of the ERP's differentiation into warm, moderate, and cold climate. All locations are also placed near to major airports, as the building demand is being calculated based on 5-year average weather data, which is most readily available in these areas. But now let's dive into one of the case studies. As our first example, we have chosen Denmark, and that for 2 reasons. On the one hand, Denmark has today one of the most well-defined official nearly zero energy building definitions of all EU countries. This definition has already been incorporated into their future building regulations law, the BR 2020. And on the other hand, Denmark also has some of the toughest requirements around, as from 2021 onwards, all new built Danish homes will have to use less than 20 kilowatt hours of primary energy per square meter per year for heating, hot water, ventilation, and auxiliary building demands like fans, pumps, etc. In addition to this very low primary energy allowance, the Danish regulations are also heavily driven by a fabric-first approach, as the average heat losses through opaque parts of the building, that's your walls, your roof, basically everything without glass in it, have to be no higher than 0.15 watts per square meter Kelvin. This is bringing it close to Passive House standards. In addition to these 2 requirements, there are also 2 limitations on the temperature levels inside the building during summer, but no requirement on the use of renewable energy, as Denmark is expected to have surpassed a 50% renewables share on a national level by 2020, and also because the 20 kilowatt hours per primary energy per square meter per year make the use of renewable energy almost mandatory. These very challenging requirements to the building envelope are the reason why we have chosen to look at the performance of micro-CHP systems in Denmark in this webinar. If we look at the minimum requirements for a building under the BR 2020 regulations, we notice that the overall building losses are less than 18 watts per square meter Kelvin, and that the heat load of the building is very close to the 10 watts per square meter, which are commonly associated with the Passive House standard. For our building of 140 square meters, this means that the annual heating and hot water demand is only 6,500 kilowatt hours per year. Now let's look at how 2 different types of micro-CHP would fare in such a building. First, we're going to see that an engine-based micro-CHP system with an electrical load of 1 kilowatt would have a thermal output which is sufficient to cover the heat load of the building even on the coldest days without a backup burner. Yet, the amount of electricity produced is not sufficient to offset the gas demand of the appliance. The primary requirement of achieving a final energy demand of less than 20 kilowatt hours per primary energy per square meter is not met, but the system has a decent amount of running hours of close to 2,600. A solid oxide fuel cell, on the other hand, which has much higher electrical efficiency and lower thermal output, could achieve an offset of most of its primary energy demand through the electricity it produces. Its low thermal capacity also allows it to run for the majority of the year, mainly providing the hot water needs of the building. But how does this picture change if we try to push the internal combustion engine below the required primary energy demand? Well, this would require some significant additional investment in a better insulation of the building, mechanical ventilation with heat recovery, and solar thermal hot water production at the least. In such a building, both the internal combustion engine and the fuel cell would meet the primary energy target, but at the expense of their running hours being significantly reduced, which makes this solution uneconomical. Of course, we know that this consideration is probably not the biggest challenge that micro-CHP products are facing in the Danish market, with its general renunciation of the gas vector, which leads to an insufficient recognition of the technology in the building regulations. But this example of a very heavily fabric-first focused building regulation is perfect to show that micro-CHP products can perform in new builds post-2020. Depending on the calculation methodology applied in each country, and these vary quite a bit, France, for example, has a very positive one for micro-CHP, both internal combustion engines and fuel cells will be able to meet the building regulations, although the small residential sector will most likely be reserved to the latter technology, and internal combustion engines might rather be found in larger buildings. But let's look at our other key question now. Will reducing building demands lead to the return of the direct electric heating system, which could be a possible threat amongst others for heat pumps, but also any other technology? This is a question that we have been asked by many people in the industry. To demonstrate some of the key factors influencing the answer to this question, we have chosen to look at Germany. Here, the requirement around nearly zero energy buildings are not yet fully defined, as the authorities are currently preparing a first draft of a reform for the regulations to be published this spring. But first directions are starting to emerge. First of all, we expect that there will be a further reduction of the primary energy demand in new builds to anywhere between -30 to -50% compared to the reference building, and likely to be at the less ambitious end of the scale, knowing that currently the reduction is sitting at -25%. With regards to the building fabric, it's rather uncertain whether there will be a further tightening of the maximum allowed heat loss of the building, as many stakeholders, including the German states, are against this. Last but not least, there are currently two German regulations, one regarding the energy performance of the building envelope and another regarding the use of renewable energy in the building. These two legislations are set to be combined into one document in the future, and it is possible that the renewables target is going to be scrapped altogether, as the use of renewables becomes quasi-mandatory to meet the reduced final energy demand requirements. So there is still quite some uncertainty around the future development of the building regulations in Germany. But what makes the case study really interesting is that Germany has, at the start of this year, reduced the primary energy factor for electricity by 25%, making the prospect of achieving the building regulations with direct electric heating much more likely than before. So let's first look at the minimum possible outfit of a building. Minimum insulation, no heat recovery, no solar thermal hot water production. A direct electric system in such a building would, even with the new primary energy factor, definitely not meet the requirements. It would exceed the demand of the reference building by more than 40 kilowatt hours per square meter per year, and also not fulfill the renewable energy criteria. A heat pump, on the other hand, achieves both targets, even at this low level of the building envelope and auxiliary systems. If we fit the building with the same package as for the Danish example, better insulation, mechanical ventilation with heat recovery, and solar thermal hot water production, the picture is looking quite different though. In this case, the direct electric heating system is meeting the targets, as is the heat pump, which is now even significantly over-fulfilling them. But what could the situation look like under future regulation? Our modeling suggests that if the primary energy demand criteria were to increase by as little as 10%, this would immediately rule out the direct electric heating in the shown building again, based on the primary energy emission demand of the system. The only solution to bring direct electric heating into new builds would then be to increase the insulation levels even further than the 20% suggested here, or a further reduction of the primary energy factor for electricity, which suggests that this would be a request that should be handled with quite some care by other interested sectors of the industry. So before I hand back over to Stephen for the conclusions of the webinar, I'd like to quickly say a few words about the research the information we just presented is coming from. Our full report on nearly zero energy building regulations and their effect on the heating market will be made available to subscribers of our micro-CHP and heat pump research service at the end of March. This will be made available along with the model for testing your own scenarios and an in-depth webinar that will summarize the key conclusions of our research. If you're interested in more information regarding our research services or this particular report, please don't hesitate to contact Stephen or myself. And with this, I hand back over to Stephen for the conclusions and the questions and answers.
Two really interesting examples there, Lucas. Thanks for taking everybody through those. And just very briefly to summarise the sort of volume of information we've covered in this short time. I think it's certainly clear now that with 5 years to go, the regulatory landscape around NZEBs remains diffuse in many European countries, although gaps are certainly starting to be filled, and we know the sort of near-term direction of travel, at least in key markets like we just covered with Germany there. We've seen that micro-CHP systems can perform well and contribute to primary energy and carbon emission savings, even in the most heavily insulated buildings, which of course is a great finding for our micro-CHP subscribers, for one. As for heat pumps, we have shown how they too can be utilised to meet increasingly challenging requirements, and the stricter these are, the better heat pumps look in comparison to the competition of direct electric heating. It's still important to stress that the current and eventual landscape is very different country to country, and of course even with each one. We've not gone in depth into Italy today, but for example, Italy has 6 different climate zones with 6 different reference buildings, which could vary 2 or 3 times as well, depending on the materials used, the aspect, etc. So Italy is certainly a market that requires further investigation, and that's what we'll do. So Deltaee will monitor the upcoming developments in all these key markets that we've covered as they happen. So that's the content portion of our webinar today. We see that there have been a number of questions coming throughout the broadcast, which is great. Lucas and I now are just filtering through, and we will we'll address those ones we can today. Those ones that require a little bit more thought or that we don't have time for, we'll certainly be able to respond afterwards. And everyone who is still on the broadcast, please do keep your questions coming in. You've got the question box there, so yeah, we're delighted to get your thoughts on this topic. So one question that came through fairly early and that we didn't really touch upon, given that we looked at more northernly markets today in Denmark and Germany, was the issue of cooling. So I have a question: have you considered cooling, and will buildings in the future definitely require cooling? Lucas, maybe you want to give some thoughts on that.
Yeah, thanks. Thanks for that question. We are considering cooling as a building load in our model. What we are not able to do within this particular model, though, is to determine whether cooling will be a definite requirement. So we are running this as a scenario. Whether a building will require cooling or not will only be possible to determine based on fully dynamic simulations of buildings, and it will be different for each individual building because it depends a lot on the architectural solutions which are applied to avoid a cooling need. What we have found, though, is that whenever there is a cooling requirement, it starts to become very, very difficult to meet the building regulations in terms of the primary energy demands, and pretty much the main solutions that are then available almost all include photovoltaics in order to offset the demand from the cooling systems, in particular in the summer.
Okay, grand. Now we have a couple of questions that relate specifically to some of the slides we've covered already. Can you say a little bit more about the UK, please? Yes, we'll come back in a moment and give a little bit more of an overview of where the UK sits just now. We had one or two questions for clarification regarding the new primary energy factor for Germany. So we mentioned it was reduced by 25%. Do we have that to hand, Lucas?
Yes, so the primary energy factor in Germany used to be 2.8 up until 2014. It was then reduced to 2.4, and on the 1st of January 2016 it has been reduced to 1.8. This is in light of the fact that there is more and more renewable energy in the German electricity grid, which is obviously being factored in with a primary energy factor of 1, and therefore the demand is reduced.
Good stuff. We had a question about just what we mean by the new build market size. So in the figures we showed previously, those were just domestic dwellings. And to recap, that was ranging from Denmark last year building 7,500 domestic properties up to France building in excess of 300,000, and still pushing for that target of 500,000 new domestic dwellings per year. About Denmark, a question to clarify if the 20 kilowatt hours per meter squared per year covers space, heating and everything else. So if we jump back to Denmark, which we'll do in a moment, I think it will show. Let's just go through there. Okay. So yeah, we see 20 kilowatt hours per meter squared per year, and go back a few more slides and we can show you that covers a lot of animations. So that covers heating and cooling. Not that we expect much of a cooling load in Denmark, and ventilation and pumps. So not lighting as other markets will potentially cover, and certainly not consumer demands, or not directly consumer demands. And as we said at the time, this could be a bit different, especially to France, where there's currently a consideration to do that. Yeah, okay, well, we might as well address just the UK now. A few questions, just looking to look at that in a bit more depth. One attendee pointing out that this could all change, providing we don't remain in the EU, which, depending on what side of the fence you sit on, will either be a good or a bad result. Currently, just with regards to that particular issue in the UK, the referendum is scheduled for the end of June. Simple in-out referendum. The details of how that result will ultimately be determined are still to come out. For example, we've got 4 countries that potentially will vote in different ways, and smaller countries like Scotland, Wales could be a bit aggrieved if the overall majority opinion there doesn't agree with say the majority of the population down south or across the country. But that, as well as several other developments that are going on in Britain under the current government, have really just served to kick the can down the road with regards to how Britain implements this directive in our building regulations. So certainly there will be no movement until after this an-out referendum in June. Providing we stay in the EU, we'll then have to submit an updated strategy for our new building regulations to the Commission in 2017. With regards to how those might actually look in real life, again, still some time until we have absolute clarity on that. Prior to summer last year, the policy and the target was for all new homes to be zero carbon homes from 2016. That policy was rescinded last summer, and we don't expect much movement at all on the current building regulations over the next year or so. Current building regulations don't specify things like microgeneration, but the previous target for a zero carbon home building would deliver a building of the specification set out in the now defunct Code for Sustainable Homes, and that would be code level 4. So this code ran from 0 to 6, and 6 was passive house standard, so increasingly better energy performance rising up through the ranks. And code level 4 would specify, I think, a maximum primary energy demand somewhere in the region of 60 kilowatt hours per meter squared per year, but we can clarify that, but not very much following a fabric first approach, similar to Germany, but unlike Germany, not with the requirement to include renewables in any quantitative or qualitative manner. Of course, they would be an option, but perhaps wouldn't adhere to the cost optimal approach. It would cost developers more to build a property using renewables. So that's certainly, the UK is certainly a market that we will be monitoring ongoing for our subscribers. And if anyone has any more specific questions about the UK based on anything I've said there, please just send through. For the meantime, we will address a few other ones. We can see that, okay, your modelling was based on domestic buildings. Have you got, or are you developing a model for commercial buildings, i.e. offices, etc.? Well, not yet. This research does take into account the same issue in the commercial or say multi-family home space, but to a lesser extent than we do. Our primary focus, given the market size and the interest of our subscribers, has mainly been on domestic buildings.
Okay, we do have a few more questions, which we will, as per the last time, summarize in the document and answer there. We thank you all for your attendance at this webinar. I hope that it has been useful for you and that you have learned something new about the development of the building regulations in the European Union over the coming years. So thank you from Stephen and myself, and we wish you a good day and a very pleasant weekend.
Thanks, everybody.